Now, how does A intersection B complement? A intersection B complement equals to A minus B. And also, how does A complement or A prime intersection B is equal to B minus A? In this video, we're going to focus on how these two operations are equal to each other. So let's start with the first one. A intersection B complement equals to A minus B. So let's denote, as you can see, I have three different Venn diagrams. Okay, we're going to be using this to show how these two operations are equal. So let's start with the first one. If we are to shade A as a set using the first diagram, where are we to shade? So let's say the first circle over here at the left hand side denotes set A, while at the right hand side it denotes set B. If we are to shade set A, where are we to shade? Now it turns out that in order to shade the region of set A, we need to shade all this circle, that is all the area that include set A. So therefore, we have to shade all this region as set A. Okay, so this is set A. Okay, now what about B complement? Where are we to shade if we are to shade B complement? Now, what exactly is B complement? B complement means not B. That is, areas that doesn't include set B. Okay, now it said if A denotes the fourth circle at the left hand side and B denotes the second circle at the right hand side. Now, in order to shade not B, where are we to shade? Which is what? B complement. B complement or B prime. Now it means we are to shade all the regions excluding B alone. So therefore, we are to shade all these particular regions. Okay, so hopefully you guys are able to know where exactly I'm shading. Okay, I'm only shading outside circle B. Okay, I'm only shading outside circle B. So I think it's pretty okay this way. So that is it for not set B. Now the next thing we need to figure out is A intersection B complement. Do we find out any common region being shaded between the both? Pause the video and try to figure this out. So in order to shade A intersection B complement, we need to figure out if there is at all a common area being shaded between both of them. Now it turns out that this little portion of set A is being shaded here, and at the same time it's being shaded here as well. So therefore, the area to be shaded for A intersection B complement is this particular area. So now, how does this really relate to the difference of the two sets? How does A intersection B complement relates to A minus B? So now let's look into it. So let's say we have a circle to denote set A. Then we have another one to denote set B. So if this represents set A and this represents set B, now I actually want to find a difference between them. I want to take B set out of set A. Now we will observe that set A and set B turns out to have what? Intercept each other. There's an overlap between them. Okay. Now in order to remove set A out of set B, okay, then set B will be taking some portion of set A along. And please take note, this is also going to happen in the vice versa. What I mean by that is that if at all it is set A we want to take out of set B, then set A will be taking some portion of set B along. Okay, now it is set B we want to focus on. So taking out set B from set A, okay, that is, we want to dispatch them. Set B will be taking some portion of set A, since they are what? They are intercept. So we are going to be left with something like this. Now, if we are left with something like this, I want you to pause the video and try to compare what we are left with the result of this. Are they the same or not? The questions or the answer is yours. Now it turns out that the results are the same. That is, the little portion we are left with is still the same as A intersection B complement. So therefore, we can conclude that A intersection B complement will be equals to A minus B. That is, set A minus set B. As soon as we remove the portion of set B from set A, the other portion left for set A will be equals to A intersection B complement. So hopefully you guys enjoyed this video. Please, if you haven't subscribed to my channel, make sure you do that now. So see you guys in the next video. Thanks for watching my video, guys. I really appreciate that. Thanks. So I will want you guys to use the techniques I just used to show the second properties, which says A intersection A prime intersection B is equal to B minus A. Okay, so you should use that as an exercise. All right, so see you guys in the next video. Like I just said, thanks for watching my video, guys.